We have with us Scott Walter, aka Humanoid Botangelist, who is an expert roboticist and one of the leading voices in the humanoid robotic space. Hi, Scott. How are you?
Good. How are you doing, Devang? It's been an interesting week of news, actually, past 2 or 3 weeks. Been quite a lot of news.
Yeah, I think for the whole month, the news flow was crazy, but the last week was even more.
Mm-hmm.
And what did you think was the most interesting one out of all the announcements?
Of all the announcements, wow. Making me choose. Well, let's see. If we're going to go purely with hardware, probably the XPeng announcement. And if we're going to go purely with software, then probably the Sunday on Wednesday announcement was pretty impressive. And
Right.
then, of course, if we're just going to be talking about deployments, then we're talking about UBTech. But there's definitely a lot of news out there, and probably some announcements that slip through the cracks that are worth getting a little bit of attention. So yeah, where do
Right.
you want to start? Where do you think is the most interesting place? Chronologically, do we wind the clock back a couple of weeks?
Yeah, it's hard to remember, but I wanted to start with XPeng being the most viral one out of the all, and then we will go back a little more for Unitree later in the episode. But the XPeng one was the slightly controversial one and quite viral. With they have announced.
And why was it controversial?
So this is the next generation. I'm playing the video around now. The next generation Iron Robot. And you can see why it was controversial. The robot looks quite lifelike. It's a full adult human-sized robot, but it's probably the first robot with 2 versions, male and female. And they brought a female version on stage that looks quite realistic. It walked quite realistically. And I got a lot of comments saying that's not a robot. It's a person in a suit.
Me too.
So that was the controversy.
That was the controversy. Now, who is the first CEO to make a suggestion like that their bot will be so good that people will think it's actually a person in a suit?
That was Mr. Musk.
Yeah, I think back in the summertime. But he hasn't revealed a bot yet that it looks like a person in a suit, except for, way back in the day when it really was a person in a suit. And he's kind of brought that up a couple of times. But he basically set the stage for what happened here, because who kind of planted the seed of the rumor that it might be a person in a suit, or people think it's a person in a suit? Do you know where that started? Right there. The CEO, in his keynote address, he said that. Okay. He actually said that. He said that people think it is. And of course, when you say something like that, people are going to think it is. Right. And he started the controversy. And I think it was almost intentional. So, it's a fantastic job that they did, that they were able to make it look so lifelike in 2 ways. First, the outer covering and everything. I was looking at really closely to sort of see, if there's any obvious things you would normally see where the actuators were or something else. And it wasn't immediately obvious that it was. And of course, the walk was just so fluid and beautiful. It's like you could believe that. Yeah. It was still a little stiff in a few places, but the conspiracies could be, you could train an actress to be able to do that. There's no problem, and everything else. And those little bumps that you see out there, that could also just be part of the costume. It's not for real. I was just not sure whether it was the new generation or the old generation, because the hands on here are the old generation hands. So the new generation hands they were showing, they do not have them yet. They've made some rough mock-ups. Not sure if they have a prototype yet. And I believe they could have fit the old iron in there. And I believe the old iron probably could walk close to like that, because it already had a very impressive gait. But they added a lot more kinematics to this, that maybe the old iron cannot walk exactly like the Iron Maiden here, because she has more degrees of freedom in the waist. So she's got a full 5 degrees of freedom in the waist. She's got a scapula up here, for the shoulder movement. So they added so many other degrees of freedom that really allow it to go. Now, do you know why they chose a catwalk? You get any idea?
No.
Well, part of it's impressive is it's like 1 foot in front of another. So that does show a little bit of balance. It's almost like walking on a balance beam. So it's a bit tricky. And a lot of people, when they try to do the catwalk, they would almost fall over themselves. But the other thing is, as nice as these bots are able to walk, they don't walk very fast. And it's kind of the thing is, like, all these bots that are using linear drives in their legs have not really demonstrated human speed as far as a gait yet. So the way to disguise the fact that your bot doesn't walk very fast is actually come up with a walk that's designed to be slow. So everyone was talking more about how realistic it looked like, as opposed to, it's not really going that fast. So, so there's a lot of very interesting things, but it's definitely real. I believed it real. You could see that in the unveiling, they've leaned into it. I understand someplace in Shanghai, they're actually, this is the bot that was out there that was cut up and the pair of scissors are on display. Everything is going to go into a museum. So, and it's a brilliant social media move, I think they really ginned up the controversy a little bit.
Yeah, and they had a second, like after the AI day, they had a follow-up event and they called people and press and everyone. And the CEO brought one of the engineers saying, okay, cut it open. And they had never cut it open before like this with the scissors.
Yeah. And
so just to show that
she had a hard time doing that. So that says something about the durability of that skin, that, you're intentionally trying to damage it and try to get through there. I mean, overall, there's so many things about this design. And I know this is like supposed to be a weekly roundup, and you'll probably find me in all sorts of other channels about that. There's just some really cool things about everything that they've done. And adding those extra degrees of freedom. It's a beautiful looking bot. We can sort of see what's in there. It really makes you start thinking about what degrees of freedom are necessary or not necessary.
Right.
They've clearly put in a lot of degrees of freedom that most engineers say, we don't really need that. But it'd be really nice to have. I mean, every engineer wants to put those degrees of freedom in there. No doubt about it. They would like to do it. They just don't know how to justify it. The mass, everything else is going to be in there. But if you're trying to come up with a bot that is convincingly looks like it's a human, you would need those degrees of freedom.
Just from the look of it, it looks very complex compared to, let's say the PD-botics?
Yeah, PND botics. Well, part of it is because you get those extra degrees of freedom, and and you're not taking advantage of any of the redundancy. But they did some beautiful things in changing this from the original iron. A lot of the actuators are definitely smaller. They added an extra rotary to the hip that was before done by a linear actuator. So they're able to drop one linear. They moved the knee actuator from basically the hamstring, from the quads back to the hamstring. They put it in the back because everyone else actually has it up front. And the thing is, their mechanism, the inverted Herkins mechanism that's down there, was kind of poking out. You would see that when iron would do a complete flexion of its knee, and it's like, wow, that doesn't look really good. So as a result, they got it in the back now, so it's well hidden. And also, they managed to get the flexion joint up a lot higher on that. So the problem with this kind of actuation strategy, which is, it's actually similar to the Optimus actuation strategy, but they got rid of that offset, the deep offset from the abduction axis on down to the flexion that almost lined up. And so the way they redid the packaging, I think, is really nice. I love the job that they did. And it's not surprising because they've actually been working on this bot program longer than Tesla. So I think this goes back to like 2019 or something like that.
Really?
Whenever you think of any humanoid project that's pre-COVID, it's old. And just about everyone else is after the fact. And you can name maybe on one hand all the companies that really were working on a humanoid bot before then.
What are we looking at here? Is this like a top view of shoulders?
Yeah, that's the back. That's looking from the back, and you're seeing those two actuators there, which are part of the scapula mechanism. And so the scapula is what allows you to what I call hugs and shrugs. So it allows your shoulder to go up, and it also allows you to bring it forward. So that means you need to add 2 degrees of freedom there. And the vertical linear actuators you see there are actually the ones that are going to do the hugs. It's going to push it forward. It's a complicated mechanism. And then down where usually are your lats along the side of your torso, you'll see buried down in there is another pair of linear actuators on both sides that push up. So that's the mechanism that's going to be pushing it up. And of course, if they combine the two, they can get that movement. So again, you've got your Heim joints that you have to throw down in there because the fact you've got all this out of plane motion. The other thing that's interesting is it's the first time we sort of see a humanoid bot where there's an asymmetry in the way things are lined up. So the, I guess what you would call the hug actuators are so long because the amount of stroke that they need, they had no choice but to offset them a little bit. And that means the shoulder
is this the one?
Yes. Yeah. So you see one on the left side and one on the right side. So they're above each other. And as a result, you'll see where the moment arms or where the bar comes in. On one side, it's much higher up, and the other side, it's a little bit lower. And I'm pretty sure that means there's going to be maybe some slight differences in the performance of the scapula in a way on one side or the other. One of them may be able to perform a little bit better, might be easier. So that means you'll kind of have a dominant arm. It's interesting. Oh, it won't be ambidextrous anymore. It's going to either be a lefty or a righty. I'm not sure which.
Interesting. And
actually, all the joints, or let's say all the limbs that have been the hardest for me to figure out, has been the head. You know, you'd think that would be like the easiest one to going on. And it's a little bit of a mystery. I believe they have 3 degrees of freedom up there because it has to be 3 for everything to add up. But I can't quite see where they're doing it. So at first I thought they had an actuator down here in the base of the neck that would rotate. But when you try to find it, you really can't find it. And when you look at a couple of views, you can see the attachment, but you're not really convinced there's an actuator there. There is one that goes horizontal. So you can see a really big actuator in the bottom that allows the head to crane forwards and backwards, but the rotation's not obvious. And from a couple of videos, you can see that the head can cock this way and definitely kind of look like that. So, oh wait, I think it could definitely do a turn, but I think the turn is actually happening up in the cranium and not down at the base of the neck. And then they have this also, it's able to side to side. I'm not 100% sure how they're doing that. I think they might have some sort of kind of what would be an RSU mechanism, because when you look at the front neck, there's some almost looks like 2 linear actuators coming up. But when you look at that, it would only give you the Y and give the X and not give you the Z. And it's like, well, wait a minute, where's the Z coming from? So I think I haven't figured out how that neck works. And eventually we'll probably see a good picture, because like the only good picture they had of the head, they had a big towel wrapped around it. I don't know why the towel was there, because everyone was convinced that it wasn't a robot, that there was a person in there. And everyone kept on saying, oh, it's an amputee or this or that. You're just going on down there, to the point that it's basically a disembodied head. They took a real person's head and connected it to that, and the rest of it's a robot. So it's been hard for me to figure out what's really going on in there, because I don't have a really good picture of what's going on. But they have 82 total joints. And it's pretty clear they have 3 here. They have 5 in the waist. And the 5 in the waist is like a big shocker. It's like, that's a lot. It's like everyone is trying to, usually it's 0. There's a lot that are 0. There's some that are 1. And everyone is kind of going towards 2, because a lot of them have tried to have 3, and it's a bit kind of complicated. And they realize, oh, do we really need that extra one? So everyone was sort of gravitating towards 2. And so here they go, whoop, let's go 5. So they just skip right past 4. Yeah, we'll go for 5.
And the CEO and the founder, XPeng, mentioned that they are going into mass production next year, and they're planning to make 1 million units by 2030. Yeah, which is quite ambitious.
That is ambitious. That is ambitious. Now it's not clear, because they showed after this some posts about them going into production, and they were showing the production hall, and I think there's even some clips in the keynote. And all the components in there are for the original iron, not for the new one. And so I'm not sure what they're going to start the mass production of. I assumed it was going to be generation 2. Now it looks like their generation 2 bot also has, at least the option to have the Gen 1 hands on there, which, and there's like an interesting tale. He was talking about the commercialization, where it's going to go, and everyone assumed this is going into your factory, right? And it's like, yeah, we did tests in the factory, and after a month, the hands start breaking. Just using a screw gun. So evidently the vibrations of the screw gun or something like that was enough. And that was like, I'm not surprised that hands are going to break in industry settings, but I didn't think just doing the screwing, and their hand looks to be fairly robust. So that was kind of a surprise. And they're like, it's too hard to go in the factory. So we've decided we're going to go in the showrooms first. And then, maybe eventually to go there. So they're mass producing, but I'm not sure what they're mass producing for, if they're really looking more at like entertainment, and that there would be salespeople, tour guides and stuff like that, because certainly you don't need a robot of that complexity and that kind of appearance to work in the factory. It's like overkill, what you would need there. So it's going to be interesting to see what they decide to do mass scaling of. Right. And 1 million is that's a big number by 2030. 10,000 is not hard for anyone to get to. There's a little bit of stress on the supply chain, but it's all feasible, because I think I said this before. If you look at just a 50-week year, 2-week holiday, working 5 days a week, 1 shift per day, all you have to do is produce 40 bots in that 1 shift. And that wouldn't be that hard. The only thing that'd be hard is like, well, we ran out of actuators, because you're going to take that 40 and multiply it by 30. And that's how many actuators that someone has to be supplying you. And then most of the other components should not be that hard to get. It's really going to be making sure you get enough of the actuators. You don't need that many cameras per, you need 130 cameras. That's not going to be difficult. The batteries, peanuts compared to what's going into EVs already. I don't really see any critical components except them being able to spool up the lines to produce the actuators. So for 10,000, that's fairly easy, except it's the reducers that are hard to produce at a good clip. So they would be able to get kind of enough for that until they really get the engineering down that they say, this is the kind of drive unit we want. And then their suppliers will commit to the proper tooling to be able to start producing these at higher speeds. So right now they're basically producing almost like prototypes. So they have like EDM machines, which will produce really good quality components, but they're just slow to do it. You'd rather have grinding machines if you need to build gears and stuff like that to start spitting them out. So in order to make that leap from 10,000 to 100,000, their supply chain has to start doing that. And there's a lead time for equipment. You just don't snap your fingers and like that. Ask anyone about the gigapress. It's like, it takes a couple of years, the back orders on that. And I've done a little rooting around because I kind of know what's going on some of the CNC machines, the specialized machines for making some of this equipment, and called some of them up. And some of them, the back orders are like, are starting to be a bit long. Just cannot get them right away. So that's an indication that, these things are needed. And so 100,000, you could probably get there for a year, but, that's going to require a lot of work. And then that next 10X, it's hard to see that you could do that 10X in just 1 year. Maybe, I could be completely wrong that it's the 10X from 10 to 100,000. That's hard because once they do that, they've invested in that tooling, and then that tooling just allows them to turn up a dial and like things start coming out a little bit faster. But it's possible to do it by 2030, but the more you kind of dig in deep, it's getting harder and harder because everyone is using the same supply chain. And like Leader Drive and My Actuator and a bunch of these other companies that are producing this stuff, they can only produce so many. And, if they have to supply everyone in the world at the same time, they're not producing enough for 1 million bots. They might be having to produce enough for like 10 million or 20 million. Yeah, that's a lot of stress.
Yeah. So talking about imitating humans, there was another company was talking about imitating humans, but for the AI.
Yes.
So there's a new startup that it has come out of stealth this week called Sunday from Mountain View. They have a wheeled robot for homes. In this video, doing tasks autonomously. The founders are one of them is a dropout from Stanford, but has worked on Google's Aloha
but not
project.
just any dropout, okay?
Yeah, PhD dropout.
They should have handed him a degree on the way out because of what he did in the Aloha project. I mean, there's no doubt about it.
And the second founder is also a robotics PhD who has done some good research work. One of them was let me play the video of that one.
Yes.
So that was the UMI research from Stanford. And this one was the same concept that they are using for Sunday. So Sunday has built upon this research in a way where people are just operating these grippers with hand to collect data. And so you have the data from the cameras, from the grippers, as well as the IMU data for the positioning. And that transfers really well to the robot, not just because of the vision data, but also the force feedback.
It's really good. So, it also becomes, very kind of egocentric kind of data capture. And that's the beauty of it, is that the teleoperators, you just slow down. Everything, time just slows right down for you to be able to do everything. You're never quite sure. You don't have the finesse. When those grippers, they become quick extensions of you, and it's very easy for you to do that. So you can perform that task much faster than you can telerobotically. So the quality of that data is much better. Like you say, the force feedback. So I think it's a very interesting data capture. The other thing I like about it is that it seems like it would transfer to different embodiments pretty well. Maybe not different grippers, because the idea is that you want to have the same kind of gripper there. But just think about it. They moved it into the embodiment they have, and everyone wonders, is it going to just have to be Memo? Is that the only thing it's going to work for? It's like, it probably could work for any form factor, because they're already just having to figure out how that body has to move to perform what they want. they have enough information. I think it's a very clever way of doing it. The other thing I think impressed me more than anything else is their stealth. I mean, they literally were in stealth. There was absolutely no rumors or anything like this. We're a little bit plugged in, and other people I know that are really plugged in, they were kind of surprised, like, how come we didn't hear about them ahead of time? Our network let us down this time. So, I mean, that means they can keep a secret pretty well.
Right.
And of course, a lot of people might have wondered, there were probably some people who were just like, where'd Tony go? Why'd he quit? Why did he drop out of school? I mean, he had an awesome PhD, and they were like, oh, he must be doing something. And of course, this is what he was doing. And I'm quite excited about it from what I've seen. And so are a lot of the other experts who know what's going on here, that it's quite impressed. And once again, we have to turn the clock back to when Aloha came out. Aloha just kind of shocked everyone because we had all these expectations of seeing stuff from Tesla, and we weren't really seeing a whole lot of development. And suddenly, these scrappy researchers from Stanford come out and using just off-the-shelf arms and like really, really bad end-of-arm tooling, just standard grippers, which are anything like hand, had a level of dexterity like what we're seeing here with a sock. You could never imagine you could perform something like that. And they were zippering up jackets, tying shoes, doing flexible tying of things, Ziploc bags. I mean, I couldn't believe it. And that completely changed my perspective on what dexterity was all about. And you begin to realize dexterity is more about intelligence than it is mechanics. And everyone's obsessing about getting the perfect mechanical hand. You may be doing too much, because those hands may not have the robustness and a lot of other features that you want to have. So you've got to find out what is the minimum. And the other problem is data capture. It's like you can have this great hand, but no one can figure out how to actually teach the hand because the teleoperator can't really feel what's going on. So the UMI approach is a very clever approach to solve that kind of problem, as well as we see here. The big thing is the long horizon planning. So clearing the dishes is very hard for a lot of AI-driven robots, because they get kind of lost in the middle and not sure what they're supposed to do anymore. So that's also very impressive what they've been able to do.
Right. And they are a full stack company, so they are making hardware and software in-house.
And that was also a shift, because Aloha was like off the shelf. So, your assumption, if you heard about, okay, Tony's going to say, oh, he's probably going to be more like Pi and Dyna and just like focus on that. And they're not going to care about the hardware they're going to do with it, because there's a lot of effort in building your own hardware. And clearly they were like, you know what? It's hardware and software. It has to go together. You cannot decouple them. You need to be full stack. So that's the one thing they learned. And then they wanted to come up with something pretty quick. And overall, I think it's pretty darn good. And again, it's going to change the discussions around wheeled versus bipedal. And it doesn't settle the dispute one way or another, because everyone will point out it can't do stairs, it can't go upstairs. And again, this is this whole thing of everyone chasing perfection. And my counterpoint to that is like, stairs, don't worry about stairs. If it can't do floors, stairs is not the problem, okay? Make sure it can do the floors. And if you're so satisfied with it, you start complaining it can't go upstairs, then they've done something right. And that's what you really need to do. Yes, there will be parts of the house it can't get to. I'm not sure it can like go into the bathroom and clean the toilets, because usually the closets in there are really tight and difficult to get into. Depending on how someone's bedroom is laid out, it may be difficult to get right in the bed. So you have to have a little bit of space, but it's not as bad as maybe some others that seem to be a little bit more cumbersome. There are many households that this will work in, and that's all they have to do is make sure it can work in a lot. It doesn't have to work in all, but
and like you said, I think their approach is for the AI model is quite flexible. So the data collection part is the gloves and people collecting data.
And also probably a hat that has also a camera up there. I think they have a GoPro up there. So they have some egocentric, and that's great. That means there's nothing that ties it to any form factor at all.
Right. No, I also, so once they collect the data, then they transform the data so that they like impose that data on the robot form factor. So that step is different from the kind of data they get.
Yes.
And so they transform that into a like kind of a synthetic data for this particular robot. So in future, if they want to make it into like bipedal robot,
excellent job.
They can do it.
Whatever they did to do that transformation is outstanding.
Right.
because you can see it's not like the bot positioning the body somewhere and then the hands doing something and repositioning and then the hands, it's, the hands and the whole body are moving at the same time. So I'm pretty sure that they've got that part down. You can change the embodiment and it won't be an issue. Again, the base was designed by the same engineer who worked on the Matic vacuum cleaner. So
Right.
you can see a little bit of the family resemblance there. It looks like it's not going to damage furniture. My first impression was like, oh, I'm not worried about that banging in the corners, anything like that. It's not going to get damaged. It's not going to damage other things. It looks really nice.
Right.
I think the one thing that surprised me is, you know how much this weighs?
No, I
How much
probably
guess?
saw
How much
it.
do you think it weighs?
60 pound, 60 kg.
Well, let's see, pounds, that it's probably a little bit more. So it's 170 pounds and
Oh, wow.
170 pounds. So I think it might be around 70 kg, something like that. So it's pretty heavy. It's
Right.
up there with like Optimus in Figure. It's not in the 1X class that you would expect. It looks very light on the way up, but they probably have like a lot of mass down there. And so that's always a concern for safety. So you've heard me say it before. It's like, when is the robot going to be in the homes? And it's like, not until they're safe. This bot screams safety right from the beginning. It just looks
Right.
like it's safe because it doesn't look like it's going to fall over. So
Right.
there's a lot of mass there. And there's a certain amount of mass in the telescoping lift that those things are also pretty heavy. But the rest of the bot probably isn't too heavy. It looks fairly soft and fairly safe. And
Right.
again, like first impressions that a lot of people have are extremely positive when it comes down to, would you allow this in your home? And I don't know if you've asked like your own family or friends, if when they looked at it, what their impression was. Like, would you let this thing in the house? Would you allow that in there? And I haven't heard
I
a no from
asked.
anyone.
Yeah, correct.
Yeah. And there's two reasons why. I think the first is it just looks so friendly. Everyone loves the look, the aesthetic. So that was done very well from a product development standpoint, that it looks friendly enough. It's not imposing, doesn't have the Terminator vibes. I think some comment somewhere is like, it's the first humanoid bot that doesn't look like it's going to kill me in my sleep. It's like, and I think that is a really good comment because,
Right.
yeah, some of the others kind of give you those creepy vibes. But the other is that, even you take Neo, which looks, very soft and not threatening in any way, it's still bipedal and people don't trust the bots. They think if it's a bipedal bot, it's going to fall over.
Right.
No one has had that feeling with this bot. They say it looks very, very stable. They think it's very safe. They would be happy there. Now, some people might say, well, they're not necessarily always safe. You go over a bump, as those things can wobble a little bit or do things like that. But still, the first impression is there. And a lot of times, getting that first impression, that the willingness to do that, is a huge step. And so
Yeah.
they really nailed it that way. There's still issues that could be problematic, when you have that long boom that's get you up very high and you have the wheels, and depending upon how big those wheels are and how flat your floor is, you go over just the slightest little bump somewhere. And if you're carrying a tray of dishes, you're going to kind of have to be able to stabilize that. And that's very hard to do. You can do a lot of it electronically, but there's still a lot of physics there you're going to deal with that you can
Right.
dampen it, but it's really hard to get. So it'd be interesting to see how they're able to handle that. Part of the way they handle it is it might be that it's just slow. Yeah, we're seeing this 5x and 10x, so we're not seeing the real speed. So if it's moving slow enough, you may not have those issues.
Right. Yeah, it's very interesting.
Yeah, the
And it's
dexterity is
fascinating
great.
that
Yeah.
we still get like a good promising startups in this space, not just in China but in US also.
Yes. And again,
Yeah.
this is very interesting because of some of the breakthroughs that are happening from the autonomy side and the data capture. So it's also showing a potential architecture that may be out there for that, and that others will probably start to copy a bit more or look at it. And
Right.
I have the good fortune that I'll have a chance to talk both with Tony and Cheng on Tuesday about this. And yeah, I've got some questions. And again, look at that. It just doesn't give up. I have a hard time getting the tabs also out of there. And, but eventually it succeeds and it gets it. So everything they did. And the other thing I point out that's also amazing is that after it closes the door here, it knows to turn it on. And I wonder how successful it is when it activates that, whether it really, because a lot of times I'll push over there as well and nothing happens. So you've got to try a few times. And how does it verify the confirmation? But we can see the hands have enough dexterity to get the job done. A lot of jobs. It's not
Right.
going to thread a needle. There's going to be a lot of things it can't do, but it can probably accomplish a lot more than you would have thought of at first. Especially when I saw the initial teasers, my thought was, they can't do much with that hand, can they? And then it turns out, no, maybe you can do a little bit more. And if you're
Right.
not sure, I mean, the test is like, go ahead and either tape up your hand or put some rubber bands on it and see how much you can accomplish. You can do a lot of things, sometimes a bit more difficult, but the one thing is you have to do is you can't cheat. You can't use the abduction. So you're gonna have to do that. And they may have taken away also one of the IP joints. I'm not sure. Well, it may be that you can get quite a bit done. Tripod pose might be a little bit different because I'm not sure if they have any abduction in the thumb or whether it just kind of comes down there. So they really minimize the degrees of freedom. The important thing is the touch sensing that they have in there, which allows them to accomplish a lot of these tasks because they're getting that from the training data.
Right. Yeah. So let's move on to another interesting video, an announcement from UBTech company from China who have they have claimed to deliver a large batch of S2 humanoid robots to one of their clients. And in this picture, there are a lot. I tried to count. There are around
I did.
200.
Don't worry, I did it for you.
You did it? Okay.
Yeah.
Mine was 210. What was your number?
191.
Okay, so close.
Okay, and I'm pretty sure I have a spreadsheet for that, and I can kind of explain why. I mean, we were talking about scale before in numbers, and so the numbers they're talking about here are not nutty in any way. So they're talking about several hundred by the end of this year. I think they had a goal of 500, and it looks like they're going to exceed that in some ways if these reports are correct. It'll be less than 1,000, but there's no reason why they couldn't have attained those things because again, 10,000 is 40 a day, 40 a shift, and 1,000 would be 4. And it just comes down to you have the supply chain for the actuators. Also, how complex is your bot? And it looks like this bot has been designed to be pretty easy to scale. So it's not going to be super, super complex.
Right.
First question I want to ask you, when you saw the video, did you believe the whole thing? We're tuned in and we know a little bit about what UBTech is going. We're already aware of these announcements. So it's not a surprise to us that they were talking about a deployment. The question was whether, I guess, the veracity of the video is like, were those real bots out there? What was that the actual number? Was CGI involved in all these other things? And what was your impression looking at it? Did you think the whole thing was real, or did you think some of it was CGI?
Yeah, I did think some of them did look too polished, and they did look CGI, like the shot right now on the screen.
Yes.
And so these pictures, but in some of the videos where the bot is walking, you can see the shaking of shoulders. That kind of gives away the real robot vibe.
Right.
So I thought the first video that they posted was a kind of mix of both.
That right there, that one there, you look at it, it's like, that does not look real. That does not.
Right.
Now, it doesn't mean it isn't real.
Right.
And this is the point I'm kind of coming to, is that a lot of discussion was, okay, well, you could have some real bots out there and you could have everything fake, or you could use CGI, like right here. That maybe a lot of those, and some of the transitions going to the hands and all that stuff, it was just really poor cinematography, I guess, as far as continuity of your shots, or you get a bit disoriented because you're not quite sure where you are in that hall. And once you start to make a map of the hall where everything is, you could see that everything is possible. And you also realize that really only 25 bots actually move. So while you might think that whole army is marching right now, it's only a subset of 25. And the others doesn't mean the others are CGI, and doesn't mean the others are necessarily statues sitting there. It just means they've been deactivated and are probably forced to stand at attention, either because they're able to stand at attention, in some sort of idle state, or they have some mechanical locks. They kind of came up there, just like, get them there so we could shoot this whole thing without them falling over. So when I looked at it, you had, looks like 9 quadrants, which is probably not the right term for quadrant, 9 areas, 9 square areas. What's 9 quadrants, or whatever quadrant is? And you have the one in the center. Actually, this is the one that's over on the corner, because you can see it's missing the hands. Right. So those are missing the hands, and you can see it's a 5x5 cell. And then the one next to it, which is kind of front and center, that's also the one where all the walking is done. And so you do the numbers, and it comes out to be about 191. And then there were a few, I think, off the side that were deactivated that kind of picked up in a couple of shots. And then you see way in the back I don't know if you want to call them caskets or shipping crates or something like that, but that's where all the bots came in. That's how the bots get shipped, okay? The bots do not walk in the back of the truck and stand at attention and drive off because they're going to fall down, okay? That's theatrics. They're allowed to do that, okay? So those are the actual shipping containers that they would have come in. And sometimes they may confuse people depending upon the views. It almost extends everything back. As far as the appearance and everything that's on here, they have, this is, I think, the polished version, and they also have the raw footage. And when you look at the raw footage, oh no, this is the raw footage.
This is the second,
door in the back. So yeah, if you go back to that previous scene there was like a blue door way in the back, right there. You see that blue door? In the final version, that blue door is not there. So they did some touch up. There's some post-production they did. And also the walls and the quality of things look a little bit different. And they did a lot with the lighting here to almost make the shadows intentionally disappear. So you don't see them there, and you also see the floor color. And there is a picture of the whole crew standing in front of it where they took like a big picture of the whole group. And if you look at the colors there, it's more earth tone. And this is more like gray tone. And this is more dystopian kind of tone, or I think almost iRobot, because the very opening scene with the door opening up is like right out of the iRobot movie, which was still, CGI, and also had very much the gray tones. So they were trying to do maybe a little bit of an homage to that. And the result of that, all the different filters and the way they set the lighting up and stuff like that, is a lot of these scenes looked like they were CGI. Be convinced that they were CGI. Some of it may have been intentional, just like XPeng was like, you started up a little controversy and then you get all this social media traction. UBTech, actually, as a result of one CEO who did not believe that this was actually real, thought it was CGI, gave these guys over another 1 million views on X. The last time I looked, and the view count might be a little bit higher as results. That was kind of an interesting ploy on their part to intentionally do these things that makes it look a little bit different. So I think there was definitely some post-production touch-up on a few things, a couple of scenes that were shot almost to make you convinced it's that way, to get confused how the hands moved around, a little bit of what I would call stop-back motion. So when you saw the battery packs being removed from the back, you get these really weird shadows that aren't normally there. And you can see from the drone footage that they showed on the raw footage, you can actually see the production crew that's there. And you can see the big bright lights they brought in for the illumination. And they took those and put them over the side and put them down there, and they intentionally cast these long shadows. And those long shadows are something that would make someone think, oh, that looks like CGI. I mean, it just looks so fake. Why would it do that? And the motion, a lot of the motion they intentionally sped up. So like when the head snapped to the side, it just happened so fast and so unnaturally. And I just sort of wonder, it's like, okay, that was sort of designed to make it look like it wasn't quite real or natural. And the same thing with the movement of taking the battery packs out, is it looked like claymation almost, that kind of stop action motion. And then they interspliced a close-up of that right there. That looks fake. And then before that, it looks real. Those are all real.
Right.
But they took a shot actually in that same hall. So it's not like at first I thought, well, that might've been from like an old video that maybe they kind of brought in. I looked at it, it's in the exact same place, except at that point they bothered to actually have high resolution. And then there's like no doubt about it that was a real bot with the others. So it's almost like it's designed to trick people and designed to stir up the controversy.
Yeah.
But I think the one thing someone pointed out, it's like, it was all very nice to see this mass delivery, but we're not actually seeing them doing anything. We saw them walking, but we really didn't see them doing anything with hands. We know they're going into a logistics. Well, we believe they're going into logistics because they've been showing a lot of videos around logistics. And it seems like the bot and everything is capable of being able to work in a logistics kind of setting. What we'll have to find out is that in the end, how successful this mass delivery is. Are they actually able to hit the ROIs? Are the customers really happy? Are the customers returning the product, or are the customers asking for more? And that we won't know for a while. But up to this point, I mean, UBTech kind of won the week last week as far as the mind share when it comes to humanoids.
Right. Yeah. One of the major clients of UBTech are the data collection operation. So they have, they may not be worried about ROI for now.
Yeah.
But Figure and Agility definitely are. And so Figure shared some numbers about the operations at the BMW factory, and they've moved around 90,000 parts and placed them on this thing for the machines to pick up.
That's like a fixture table as part of the loading for the spot welding
Right.
cell behind it. So this is usually where a person would come in, load the pieces of sheet metal, stand out of the
Right.
way, let that turn. So it's a big turntable, and then goes in and does the welding. Now, this is, I think, the X3 or something like that. So I don't think this is a high volume vehicle, because my understanding is the takt time is something like 89 seconds. So that's a pretty high takt time. When you get to a lot of higher volume vehicles, usually they're down around 49 seconds or something like that. So
Right.
they had plenty of time to be able to do it. It's more than enough time for a human operator or anyone else. And so I'm trying to remember the numbers that were in there. I think it might have been in the 40s or something like that. So they had like spare time to be able to go ahead and do that. So it doesn't
Right.
sound like they would have halted production or stopped production because of any sort of failure like that. We could see from these images that, the bots got dinged up a few times, which means, there may have been a few times it fell down. And, we don't know whether that caused a production, a minor production delay. But of course, what they would have been doing is there would have been a person there the whole time, because this is a pilot. And if something goes wrong, they would have jumped in pretty quickly to make sure it didn't stop the production. And I think the other figure is like, it resulted in something like 30,000 cars actually. So this resulted in assisting the production of 30,000.
Right.
Between the 90,000 parts, that means 3 parts each in there,
Right.
and you already have hundreds of parts that make up the assembly. And just the
Right.
body alone, it's like the whole thing goes thousands.
And so today or yesterday, Agility Robots also shared some data about their operations at a GXO warehouse. They have moved 900,000 totes
Yes.
in the facility. And so that's also very impressive. But do you think either Figure or Agility is able to provide enough ROI that these clients would buy a lot of robots from them in future?
It's hard to tell if they've achieved that yet. And I think for a couple of reasons. I'm not sure how close this competes with humans that are out there. The other thing we can see is that there's still a lot of safeguards sort of put up here, and it looks like it's still just a test area. If I remember, I think it was back in July that it was the 12-month mark for this. So, 13, 14, 15, it's like, it's about 16 months now that it's been there. So in that period of time, they just hit 100,000. You would have hoped that the number would have been a lot higher than that. It's a great number to already hit. So that's already impressive enough, but it's not clear. It's also not clear from the press release. So when you read the press release, it was celebrating that number. And I think the headline was something about Agility is ahead on the race to ROI. and it's like, well, that's the first time I've heard that term out there.
Right.
The race to the ROI, almost admitting, well, we didn't quite get the ROI that the client wanted. But we believe we're getting closer, and that we're closer than anyone else. So and if you look at, what XPeng, they tried it, and they also said the ROI isn't there, because he even said in there, it's like, after a month it broke down, we had to replace the hands, and that, it was actually cheaper to stay with the workers. So that's like another admission there. What we don't know is whether BMW is re-upping on this, or whether they kind of gather enough data that they want to process that and sort of decide, okay, maybe it's not ready now. Maybe we need another a year or two before everything is ready. So we don't know about that. And of course, the other thing, as far as ROI, I was expecting to see Optimus already in the Tesla factories doing some stuff, because that seems like it would have been pretty easy. And the fact that it's not is also a big question, is like, when are these things going to start having that return on investment? And
Right.
when are they going to actually be doing useful work? And in the end, the definition or let's say the KPI that says they're doing useful work is return on investment. And that the combination of a lot of things that go in there.
Right.
And one of them is like overall efficiency. The OE, the overall equipment efficiency, has to be, higher than 85%. They like to get in the 90s or something like that. And that's a combination of a bunch of things. And it's mainly making sure they don't break down, that the part quality and all sorts of other things are going on pretty well. But then there's the other is that, it's great that it performed at human levels for 2 hours, But it can't just do that
Mm.
for 2 hours. It has to do it for the entire shift and for the entire day and for the entire week. And how long can they do that without having severe maintenance or other failures that, like, cascade and cause other problems on there? So, you need robustness, you need reliability. And then the other that we didn't see in any of those press releases is like, okay, the bot was working, but how many minders did you have? Because if it's like one person for bot, well, you're paying that person, and I guarantee you're not paying that person minimum wage. They're probably being paid a little bit more than whoever was doing the job. So that means the cost is pretty high. So in the end, the ROI is like looking at all these things and just saying, is this cheaper than the current way or not? And if it isn't, we're not getting a return on investment.
Right. Yeah, it's kind of also a chicken and egg situation of scaling. If they are not able to sell and provide value to the clients, you won't have incentives to scale up the factories to
Yes.
produce more
Yes.
of these.
Exactly. But yeah, and scale is part of it. It's nice to be able to reduce the cost of the bot, but it
Right.
really just comes down to if you're not able to perform it because you're not robust enough and you're not fast enough, that's why you're not scaling. So it's not that you're not building enough of these things. It says that your bots aren't worth scaling. And until they're
Mm.
worth scaling, you're not going to see that. And, but of course, to get to that, you need these pilots. These pilots are very important. So, we are indebted to BMW, we're indebted to GXO and all the others that are taking these things on. And I think they know that it may be a few years, but someone has to go ahead and help with this work and do this research.
Right. Yes. Elon also has big plans for Optimus, but like everyone, there's still the AI side of it is still the open-ended research project. He wants to sell a lot of robots for the consumers, and he's really happy now that that his CEO compensation plan is passed, and so he can go ahead with the ambitious plans for Optimus. So
Okay, so now
Joe
you're gonna fill
Tegmeyer,
me in. Yeah,
yeah,
I haven't. I've been so busy chasing all that stuff. I haven't had a chance to kind of follow that part of the news.
right,
So
right,
you can bring me and everyone else up to date.
yeah. So on the Tesla 2025 shareholders meeting, Elon mentioned that Uh, they have a pilot production for Optimus at Fremont, and the next production line would be for 1 million Optimus at Fremont. And the one after that would be at Giga, Texas for 10 million Optimus. A week or so after that, Joe Tegmeyer, who flies drones over Giga, Texas, he discovered that there is a lot of area being cleared on the east side of the Giga, Texas factory. And he has learned from probably from his sources that there is going to be a whole new factory being built here for the 10 million Optimus line. So Tesla is putting money where their mouth is for the ambitious Optimus goals. Any thoughts on that?
Yeah. Okay. Well, the first thing is factories don't spring up overnight.
Yeah.
Unless you're Tesla in Shanghai, and then it seemed like it sure did. But we know like some of the others had a lot of teething pain. It took Berlin quite a while between the regulations and breaking the ground and everything else. So these things take a little while, and you want to make sure the ground is literally cleared when you're ready. When you want to hit those production goals, you're able to do it. So I'm not surprised they'd be starting to doing something like that. The question is it a little bit premature or early? Because I have no idea what that design is going to be. So if we're being really ambitious on what the timeframes are, and I have to count on my fingers here. Okay. So let's say if we're really generous and somehow the V3 is ready to do it and they can do 10,000 next year, that's 2026. And then 100,000 2027, and then 2028 would be 1 million. That would be tough to get there. And then maybe 20. So that to me, I don't think they can hit 10 million by that point. I think most people are talking about, I think Elon in the past always said that, yeah, 2030, it would be possible to hit 1 million. But I don't think they're going to hit 10,000 next year. I think it's going to be more low thousands at best, because the design isn't there. So you can kind of shift all those things a little bit. So assuming, this is almost seems like a 2031 kind of thing. If you can do that 10 times scaling per year, like you say, that gets a
Right.
bit tough it's early days, going from 10 to 100 is fairly easy, into 1,000. And then after that, you start looking at factors of 3 or 5 or something like that. So the pilot is already up there. That, could it be a bit earlier? Or are they that ambitious that they really think they could be hitting, 10 million by 2029? So that's 4 years away. But at the same time, just because they have this facility up does not mean they're producing 10 million. You remember when Berlin finally came on production, it was not hitting its design capacity. So it usually takes a couple of years. So it could be, we need to have something, and then the equipment's got to start coming in. We're going to need a lot of equipment. The question is, how much production are they going to start bringing in-house? And that's another thing to consider, is that they're using a supply chain right now for a lot of critical components, and they may eventually want to be producing those critical components in-house and not relying on the supply chain. And depending upon the numbers they have to produce, you're going to need a lot of equipment. So again, when we look at, and we don't know what the next generation, and this is the other thing, of course, is that Elon is almost saying that, like, at this point, every year expect a new generation. Every year, 18 months, something like that is going to be the next one. So they're not going to be scaling V3 to 10 million units. That's going to be maybe version 5 or version 6, something like that. So when they get to there, we don't know how they're going to pivot on the design. Right now, they need 14 linear actuators. Those actuators, I think, need about 10 of those planetary roller screws. So that means you need 140 planetary roller screws per Optimus bot. And those are very slow to produce. So the equipment that produces those takes about 10 minutes for each one of those things. So you could imagine, wow, how many of these do I need for one Optimus per day or something like that? And if you're going to be producing a lot, you could imagine this really big hall just full of equipment that just kicks out these little planetary roller screws that are going to be needed, assuming that's what V3 is going to be needing, and assuming that V4 and 5 and 6 are also going to be the same thing. So we don't know what it is. They may not even know at this point, because things can shift pretty quickly. So if they're thinking of bringing a lot of that in-house, they would need a lot of space. And then, you need to plan. So maybe you do need to plan 4 or 5 years in advance and start the groundbreaking now. If I think about it, Agility broke ground 2-3 years ago on their facility. That was for 10,000 a year, and I don't think they're anywhere near 10,000 yet.
Right. And this was also a fascinating unveiling. The Unitree H2 robot.
Yeah. Also a beautiful looking bot.
Yes, very athletic, slim, much slimmer than the H1. The design-wise, it does look very similar to G1, right?
It looks maybe closer to R1, which is an evolved design of the G1. So there's a lot of similarities, like the waist. The waist is more like the R1 waist.
R1, okay.
Yeah. The hip, I should say. The hip, because, it still has the far hip, but it has a really strong anhedral angle. The waist is completely new. So they completely changed the waist. They no longer have the kidney style waist, because I believe they're discovering that is not only difficult for RL, it also mechanically there's some issues there. So they came up with what I have to say is a pretty compact solution for a 3DOF waist. That works out pretty well. It results in like one actuator sticking out the small of the back just a little bit, but overall they did a pretty good job of figuring out how to put that in there and make it pretty useful. You almost don't notice that. So some of the design elements that I think are very interesting, that you can see that everyone was looking at what is actually a prototype. So my understanding, it's not fully working at that time, and that is probably from Michael Cho, I believe.
Yes.
Because I've seen that so many times. And one of the things that everyone's trying to figure out is how the ankle is done. So that's the one that has been the big focus of attention for a couple of reasons. And you almost think it's the same ankle, but it's not. So it's not what we call this RSU style, which is a rotary spherical universal kind of mechanism. It's something different. It's a variation on it, I believe, for a couple reasons. One of them is that parallel mechanisms do not work very well in RL training. So you want to get rid of the decoupling. So it's a little bit harder on the training, and you want to somehow serialize everything. And so they found a way of serializing it, even though it's still parallel in a way. So I call this more of a quasi serial mechanism, that you can see that Achilles heel down the back, or sorry, the Achilles tendon that goes right on down there. That
Right.
is centered. It's not offset. Normally, both of those tie rods were offset to the left and right. This one's like dead center down the middle because its function is only for the pitch of the foot. That's it. Then there seems to be these mysterious two others. And it's like, my goodness, why don't I have one? But there seems to be these two other rods that are coming down that are designed in a way to just do the roll, which is like almost the 1 degree of freedom you wish you didn't have to monkey with, but you know, it's very important to have there. And everyone goes all sorts of effort to try to get that thing to work. And they changed the order of operations on the universal joint that's down there. Most universal joints, you do pitch first and then roll second. They did roll first and pitch second. And the result of that is the actuation for the roll joints that are coming down there do not need a spherical joint. They can do it with a traditional cylindrical joint or pin joint down there. So they work fine. And it's only the pitch actuator, that really big Achilles tendon that you see there, that needs a ball joint on there, or what we usually call a Heim joint. The other thing is, look how big that thing is. I mean, that is the biggest hunk of metal I think I've seen in any of these bots.
Yeah.
And it looks like they're concerned about buckling. They're concerned about buckling so much in the mass of that. Do you know what the material is?
Titanium?
Yeah. Now,
Okay.
it's not just me speculating that is that I just assumed it was like probably steel, stuff like that. Until I looked at their spec sheet, and their spec sheet said aerospace grade aluminum and titanium are the materials, along with plastics and a few other things in there. So it's like, titanium, I wonder where they're putting the titanium. I was like, I wonder if they put it here. And then I just said, Grok, what's this material? And just looked at it and said immediately, titanium. And it's like, you sure it's not aluminum? It says, no, you know, with all the effects and stuff like that. And it just went through a litany of reasons why it could only be titanium. So it's not like I prompted it or told it, unless it was listening in and heard me say, I wonder if it's titanium. And then, of course, I checked, well, what does ChatGPT think? Same thing. So I took those images, and a couple of them put it in there. And the fact that they said on there, it's like, okay, that probably is where it is. And titanium, the strength to weight is like really good. So I guess in order to get whatever strength they need to not have the buckling, if it was made out of steel, it would be such a much bigger piece of metal that it would weigh a lot more. And it's probably not pure titanium. It's a titanium alloy of some sort. So that's kind of a surprise that they need such a big mechanism for that. But the real question mark was, and when I was watching the ballet going around, I could see that there was some ankle roll. Because, you know, the first thing you kind of wonder, but you'll see there are times where the foot is like up there and almost at a weird angle. It doesn't go back and forth. You know, they'll get some dorsiflexion that will be kind of weird. But a lot of times you can see that if the angle of the foot is not parallel to the ground when it comes down, when it hits the ground,
Okay.
it just snaps right on that, just like really, really fast. And I was really impressed. Like, my goodness, it's like snapping on there really quick. I wonder if they're using compliance, or because I don't think a control system would react that fast. So it's itself kind of going ahead and doing that. And you can see there's times where the ballet dancer does some push off, and you kind of wonder, it's like, man, don't you need activation for that? But the more and more I'm leaning to compliance, because it's really weird. It's like, why would they have two tie rods coming down for roll when it seems like one would be enough? And you look down there and you can see what is sort of long metal pieces. But there were a couple of shots that someone got, and unfortunately, everyone that was over there was like shooting the wrong stuff. If I was there, it's like get down that ankle and get up there and get some shots going up a little bit. Instead, they were all off on the wrong side, and you get a glimpse. And there seems to be a glimpse of actually cables coming down. And it looks like the cables does come in there. And the reason why they have that long kind of stiff rod coming up down the lower part is that's where they are able to adjust the tension of it. So they have like a really long threaded stretch there, they can do it. So it's pretty clear that on both sides, they have cables coming down that then attach to it. And then cables only work in one direction, right? Tension, compression, They're going to give you absolutely nothing. So that gives a suggestion that it's probably doing that. Now, Anand, who was formerly on the Tesla team, is now over at Zipline, was kind of commenting on what it had in there. And he was sort of, we were trying to figure out, like, could this be passive or active? And they're not quite sure. And he almost proposed the possibility that it could be active compliance. So, maybe they're doing something to change the stiffness on one side or another, but overall, it's like the jury's out on whether you need active. You need the roll. Almost everyone agrees you want roll. If you're going to have a bot that's going to be in a variety of terrains and stuff like that, you really need that. Even on a flat surface, without the roll, you get yourself into trouble pretty quickly. So you need that. The question is, does it need to be active, and can you do it through some passive mechanisms with compliance? And that might be what they're doing. And if they are, that will be interesting. Now, someone pointed out that they talked about the degrees of freedom, and usually when they say degrees of freedom, they in the past, at least, they have always meant the number of actuators. But I have also noticed the notation is that when they said degrees of freedom, they meant total joints. And it's like,
Right.
okay, so maybe they do have a joint down there, and it's kind of passively controlled. I think you could do it. I really think you could do it passive, and you don't necessarily have to do it that way. And I don't think our human bodies actually have that much activation on there. I think we all have kind of compliant roles as well. So it should work that way. So that was interesting. I guess the other thing that was interesting is they went to that length and they don't have a toe box, because everyone has a passive
Right.
toe box. They agree that's a great idea. And you think that that's something that would help out, but it's not there.
Right. And the progress is very visible, and
Mhm.
they're probably going to sell a lot of these.
Oh yeah. Yeah.
The researchers already love the G1.
Yeah.
And this is kind of a
And
natural
this is
extension.
30,000 or something like that. It's actually pretty cheap. So
Yeah, the starting price is 30,000, which is
right.
which
The
is
education
similar to
one.
the 16,000 promise
Yeah.
for the G1.
Yeah.
But if you want a really useful one, it's probably going to be,
Mhm.
55 or something like that.
Yeah.
Still,
I think it's
still a good value.
Oh yeah. And they did a lot of things to try to lift a lot of the mass as close to the center as possible. Not distal, but make everything a bit more proximal as far as lifting it closer to the center. So if you were able to get rid of an actuator down there in the calf area, and this is where I'm not, as I'm looking at the profiles down there at calf, and it looks like there's another actuator in there. That's why it's a head scratcher on how they're actually doing the actuation and why they would do it that particular way. And I guess the other thing I wanted to point out is that they do a very good job of keeping it flat. And if we go back to the UBTech video, it's something that's very subtle. They put a post out there that when they start marching away, you do see the feet go down there, and you probably saw that too, that the feet will kind of bounce a little bit. But when they get a close up on the feet, you'll notice that the trailing foot, as soon as, so kind of right there, this is where everyone has to go. That if you can go like frame by frame, what ends up happening is that when the lead foot hits, as soon as you get the heel strike, the passive foot that's on the back, that's actually flat, suddenly rolls just a little bit. It loses contact and goes from a flat to suddenly on the edge the instant that you get that heel strike. And when you get the zoom ins there, and it may be a little bit harder on here, but on the others, it will come in and you can begin to see that. That was rather interesting. Again, showing the difficulty of that kind of mechanism to actually be able to react fast enough. And you think it would. And then as it continues through, as the front foot flattens after the heel strike, the rear one actually goes from being only edge contact to almost just a point contact. So it really changes the whole foot positioning back there, because that roll is not able to react fast enough. And a lot of the reason it can't react fast enough is that the torque transparency that they're trying to get is that, they can see what the torques are coming from the foot, but they can't figure out, is that pitch that I'm seeing or is that roll that I'm seeing? Because it's muddled up with the two actuators that are controlling everything. And that's why the RL doesn't like it, is it's not quite sure what it's seeing and it won't be able to react because of it. So that's the disadvantage of this RSU, which is parallel. It looks like a brilliant way of doing it, but as Jim Fan has said in the past, you've got to design for simulation, or you can kiss RL goodbye. It's his quote.
Right.
And that's why it's interesting to see when you do the close-ups down there of how that foot's going in there. And I took this into DaVinci Resolve and went through moved it one frame at a time, seeing, and like every single foot. And that's where the creepy part is, like, is it CGI? Because everyone is like moving exactly the same thing, like frame by frame, they're almost identical. And I think it's just because, hey, they're robots, you can coordinate them. And I'm sure at the beginning, everything is in phase. And then, if you go a minute later, things probably are a little bit out. But right at the beginning, they're all there. And every foot is doing the same thing, indicating it's not a fluke, that's actually what ends up happening when you get that strike. Because when the front foot is in the air, it's balancing on that one foot. And because it's balancing on that one foot, it flattens out. It has to. And then as soon as that other one comes down there's a shock to the system. The foot rolls and never recovers on that. But you look at the Unitree one, that foot's always flat. So it's very different. And so it's like either Unitree is much better at being able to control that, or compliance is the trick to actually keeping the foot flat.
Yeah, super interesting. And yeah, it's fascinating from so many angles, this space. And
yeah. And I put a post out there somewhere showing that everyone kind of wonders what's going on. You can look at it, and I don't know, maybe we can link this somewhere in the video. I had to find it, but you know how bad the search is on X sometimes. You have to go to my profile, then you have to like scroll through, but it's just like maybe a week or two ago where I talked about that. And that's when Anand kind of got into the post, and we had a really interesting exchange about compliance and trying to understand whether they could be doing it or not, or what the advantages would be. So anyone who is considering designing a humanoid bot, you should give that really good thought. I don't know what the final answer is. If I was building my own, I probably would explore compliance there. You know, really kind of look at that and see if I could do it that way and not actually have to have it active.
Yeah. That's all I had. Any final thoughts?
Oh boy, I mean, there's so many other companies we didn't have a chance to talk about that announced some stuff that are interesting. I'm sorry. Okay, so Agile over in Germany, they also announced a new bot. They all made the mistake that they kind of posted it on Wednesday when Sunday came out, and they were kind of forgotten. So Agile is another German company, very similar to Neura in a way, because they already have a cobotics division. They're well known, enough that I've modeled their bots and put them into the visual component software a decade ago.
Oh, really?
So they've been around a while, and they've come up with a humanoid. I haven't had a chance to look at it. I want to give it, the proper appraisal and stuff like that. And then also Tangible, another company in Silicon Valley, came out with a bot that's very similar to Sunday. It's also a mobile base with a vertical lift. That I guess kind of also came out of stealth at the same time. So that's Eggy, and they're looking at not only the home but also in hotels, and being able to do a lot of housekeeping kind of duties that they've been working on. And the CEO is also a very accomplished, very smart individual who left her PhD at MIT to kind of pursue this, and was also able to persuade a lot of other people. That's Bipasha Sen, also out there in Silicon Valley. So Tangible is also another one to kind of keep your eye on to see how they're going to be doing. That also like in 18 months out of nowhere, working on a full stack, working on the first generation bot. They're worth following, and she put out a pretty good post tonight, sort of explaining the thought process. It was just like a post with 6 threads and replies in there on what the thought process is, and I like doing that because I always want to see what's in their mind. What are they thinking? What is it I'm missing? What's their rationale for doing it? And I think everyone can benefit from that. So. Yeah, one more, and I'm trying to think. There's probably others, and I apologize if I haven't mentioned some other company that that you have a team of people that are like putting blood, sweat, and tears in there, and they don't make the headlines, and they all deserve to get a shout out.
Right. Yeah. It's very interesting times. Thank you, Scott, for sharing.
Yeah, you're welcome. It's been my pleasure, and yeah, we'll probably try to do this a little bit more often to do the weekly roundup of the news when it makes sense.
Right.
Because if we don't do it weekly, if we do it monthly, there's just too much.
I'll be on a month-long trip to India, so maybe starting next year we'll do this more frequently.
Yes, and unfortunately our paths won't cross in San Francisco. I'll be out there in mid-December for the Humanoid Summit. So I'm looking quite forward to that, and it's too bad we won't meet up for that, but I have a feeling I'm going to be in the Bay Area more frequently next year. So we'll definitely have time to do another live sit down.
Yeah, looking forward to it.
Yeah,
thanks, Scott.
Okay, thank you, Devang.